Hello everyone, and welcome into yet another livestream. And today we will be explaining basic math. Nope, I am not kidding. I am so very much not kidding. Let me just open this. Great. Yep, I'm not kidding. We'll be explaining basic math. Really basic. The plan is okay. So I should probably explain. Because we will start with addition and subtraction, multiplication, division, exponentiation, and well, there isn't really a term for the nth root. There isn't really a term for this. But basically, we'll start with them, then move on to hopefully trigonometry, types of numbers up to imaginary numbers, possibly quaternions, octernions, and the ones above, and then calculus. And that's the plan for today. Yeah. Why? Well, it's because there's this paper that I'm writing, and it is quiet. Now I opened. Now over here, I opened the Wikipedia page for this. In order to explain addition, I actually wanted to read the Wikipedia page because I don't really know how addition works. Yeah, addition is very complex. It's a weird operation. Like okay, I can do derivatives, limits, integrals. Alright, limits obviously using epsilon delta. I can do all of those because these are easy. Addition, that's the problem. That's the one that's actually problematic for me. So that's why we're gonna read this. Okay, but for you, I just have absolutely no idea how to explain addition. I mean, think about this. How would you explain addition? It's not as easy as it seems. Let me open one more thing. Great. There we go. How would you explain addition? It's not easy. So we could describe it as an observation based on the observation on the real world. Let me also subtraction. That's the third one in Times New Roman because we're professional. And now addition is an operation based on the is a mathematical operation based on the real world observation of summing objects. Is this a good definition? Not really. Not honestly, no. No, it's not. It's very much not. But yeah, put some music in the background, so sick. Or actually, no, I should put my research music. Which is this. This is my research music. This and the classical. Anyway, is it a good definition? It's alright. It's an alright definition. For example, if you have 4 apples, right? Let me just also put the music down a bit. Okay, if you have 4 apples, you add 3 apples to the mix, then you get 7 apples. This could be described as, and over here, insert the equation. Is there a shortcut for this? There isn't. Great. As 4 plus 3 is equal to 7. Now, it is important to note that if we are adding values together, it is the lowest level of abstraction possible, because numbers like 4, 3 or 7 describe the exact value. but nope, this. But if you are talking about adding together apples, then the level of abstraction is really high. Because numbers are no longer describing the values, only real life, only real world, probably not life yet, objects which just an abstract, not collection, concept. Yeah, because if you think about it, there isn't really a definition for an apple based on low abstraction. Like, you cannot, you won't recreate the definition for an apple based on quantum physics. That's why they are abstract. So now, let's carry on. Yeah, don't mind this, by the way. Don't mind that. Now subtraction. Actually, multiplication would be better here. Yeah. Let's first do all the multiplication. Exponentiation. Times in Roman. I forgot about that. There we go. Multiplication could... Why is it still heading 3? No more text. There you go. Oh, this is this and this. Multiplication. There we go. Misspelled, I know, but first I want to fix the font. Sorry about that. Addition. When multiplying, just describe how many times would you like to add something up. As our ride goes on, having a pleasant time. Anyway, sometimes you would like to add something up. For example, passengers are having a pleasant time. 4 plus 4 plus 4 is equal to 4 times, times 3. Yeah, let's do a couple of examples. Times n plus yeah. Multiplying by 0, you are well, there are no numbers. Actually, yeah, multiplication by 0, that this. That's which means that, and over here we'll do x times 0 is equal to 0. Now exponentiation. Exponentiation could be described as repeated multiplication. When exponentiating, you just describe how many times you would like to add something up. For example, yeah, I will expand this definition for all the stuff, but first we have to lay the groundwork like this. Then we'll have to revisit all of them. Alright, great. By the way, I should probably explain what is this paper. I'm pretty sure I have already explained, but might as well. This paper is supposed to describe everything. Well, it's basically supposed to explain to everything. This paper is basically an instruction on how to create life. I like that description. So basically it will describe everything from basic math to advanced math. Actually, I don't know if there will be any advanced math. If you consider calculus in advanced math, then maybe, but I think calculus, that's it. Through quantum physics, then chemistry, abstraction -1, then biochemistry, abstraction 0, which is not here yet, abstraction 1, which is biology, abstraction 2, which is not here yet, which is medicine, and then probably abstractions will pile up. Abstraction 1 is over here because that's where life actually begins. Bacteria and stuff. Biochemistry will be abstraction 0 because that's kind of where life begins. That's why 0. Anyway, for example, 4 to the power 3 would be just the same thing except times grand. And I think we should do the same example as previously. For now, we'll define it in a very simple way. But then we'll revisit everything when we'll define negative numbers. Because roots, division, subtraction, all of them are, I used to call kind of operations because they are kind of operations. They all could be defined without using the actual operations. For example, subtraction is just a plus -1 times b, right? That's subtraction. Multiplication is just a times, well, this is a bit more annoying to explain, but yeah. And exponentiation could be defined using this up here, just defining stuff. Great, so now also add the zeros, which means when exponentiating to the 0th power. Yeah, that seems like English. The number of values multiplied is equal to 0. Means that, and this is the one that's a bit of a pickle. We haven't laid any groundwork earlier on, which means that x to the 0th power will be equal to 1, because 1 times and no force means that this one's a bit more annoying to. I should probably add also another example, so let me just like another 2 examples. So we'll have 2, 1. There we go. Not times 0, because we're just multiplying this. Yeah, it works, fine. Okay, cool. Now, types of numbers. It's time for the fun one. So, what kinds of numbers are there? Okay, we won't mention hyperoperational mathematics. Because that would be silly. For an alternative way to group numbers using mega. That would be silly if we mentioned that. Anyway, integers, which would be both positive and negative. Now we'll have, well, actually, positive, negative. We will have to, yeah. Types of numbers. Then we'll do. Oh, what should we call all of the numbers, like imaginary, negative, quaternions? I mean, quaternions are hypercomplex, right? I do believe that's what they were called. Are quaternions hypercomplex? Quaternions. Is it what quaternions are called? Hypercomplex. Pairs of complex. No, they are not. Great. Integers. Sick. Integers, always the most annoying things to explain are the starting ones, because later on it's easy. Rational numbers. Like, rational numbers are a breeze, because the rational numbers, I can do it in one equation. Rational numbers are numbers which satisfy the following equation. Which basically means let's do this: x0 divided by x1. Okay, using r here is a dumb idea, but as a placeholder, let's do it. Where x0 and x1 are random integers, and there we go. That's it. That's the entire definition of a rational number. Irrational numbers are also easy to explain. Transcendental numbers are also easy to explain, because these are just numbers that cannot be written as an right? Oh my goodness, my mind is blank. I know the definition of a transcendental number, I just can't remember. Give me a second. No, I will be able to remember it. I refuse to believe that I forgot. I mean, I know what it is. Transcendental numbers are numbers that can be wrote down as x to the power n plus x. Am I going crazy? Transcendental. Yeah, if I number, there we go. Yeah, polynomial. Polynomial! That's the word I was looking for. Wow, I am losing my mind here. I am losing my mind here. Not the root of a non-zero polynomial with a final degree of rational coefficients. Yeah, mathematicians are great, by the way, at describing things. Just perfect, absolutely lovely. I always wondered why people, you know, are scared to learn math. Because I really wish I could skip this and go for something that's easier to explain, like calculus. Calculus is so pleasant to explain every single time. Trigonometry. But I want to do it step by step, so we're doing it step by step. So I should probably also over here add fourth, which will be obviously anti-operations. Nope, that's hyper-operational mathematics. Make it. What you are looking for is extensions. Good enough title. Yeah, good enough title. When it comes to operation, when it comes to our three basic operations, they can all be extended for some additional. That's very much not English. It's fine. Additional helpful operations. That is not English. That is very much not English. Make it. Helpful operations. Like, and step by step now. Nope, over here. Wait, what? Why? Okay. There we go. Now it works. Subtraction. For subtraction, obviously, we would need. I should probably do numbers. It's annoying. It's actually very annoying. We need negative numbers to explain this. We need negative numbers to explain this, but negative numbers should be next to imaginary numbers. I don't want to just randomly throw negative numbers here. Subtraction. Then we'll have division. And then we'll have radicalization. Nope, there's roots, just roots. There's no better way to describe it, which is very sad. Roots, and then we will have logarithms. Great. Yeah, division I would like to explain twice. First time with the relatively reasonable and a relatively easy to understand explanation, and the second time with the actual mathematical explanation. Mathematically, division could be described as, and then over here we would have fraction a divided by b would be equal to a times b to the negative first power. Yep. Roots are a bit more annoying because the roots don't really have some need of an explanation, because in normal mathematics we don't have titration for some reason. Titration is not considered a normal operation. I don't know why. Division can be explained it's not really graphically. Set of fudge. Not really graphically. How should I start this then? Well, there's so many of these. Our table of contents is getting quite massive. Extending to the other side, yeah. I would call that quite massive. And for that, actually, I should use Manim. So let me just... search Manim white, black on white background. That's what we are. No, my IP address. Dang it. It's been leaked. What a shame. What a shame indeed. Do you have maybe a code snippet by any chance?
There's a guy named Jones, lab man. He makes prints of films. He handled this print.
Actually, that is one way to do it. And that's a clean solution. Very clean one, actually. Thank you so much. Alright, great. Let me just this import modem. Yeah, actually should be from modem import everything. There's space through this. Cool. This should be text. That didn't really work. That really didn't work. I don't think the background colors changed. How about... No, I don't think background colors changed. That also seems like a clean solution. We'll have to turn this to black, obviously. Yep. It happens more than you think. There we go, great. Sick. So now all they have to do is create a number line. Oh, I thought it was called 13, but it's L3. Yeah, that makes more sense. Excuse me. Oh, inconsistent. Wait, what? How and what now? How and what now? What? Why? It's not defined, but I'm pretty certain that's how we define stuff in Python. Unless I'm wrong. What do you mean? Now it's correct. I have no idea what the heck happened. Grant, now let's just do color equal to black. And let's create this rotation because it's unnecessary. Now let's do self add line 3. Yep. Number line, number colors. Same thing. That is quite a thing to add. That is quite a thing to add. I mean, fine, let's do it. Config. Let's see. Can I just do this, please? Nope, I cannot. So that didn't work. Great. Lovely. Why am I trying to use in Madim? I have no idea. Include numbers, yeah, man, I want this to be black. This. Oh, this worked, great. Sick. So now that we have this thing, it should be from 0 to, let's say, 20. Length, let's say a 9, but probably will increase it to 14. Actually, this looks decent, yeah. Now, image is fine. There we go. Now we have this. What we need is to select this entire region So first I should probably render this, right? Great. Sick. Recent is already saved, right? Explorer, media, images, space, life and time. This, and we have this. Sick. Wonderful, amazing, great. Now, let's just select all the numbers apart from 0. Unfortunately, we cannot just change this to 1. That would be wonderful, but it won't work. Because, well, no, wrong thing. That would be wonderful, but unfortunately, yeah, that's what it looks like now, because it's offset. So now what we have to do is, it has length 9. Maybe this? No. 29 divided by 9, so 9 divided by 21. My math is incredible. Great. Now dot shift where right times this 2 maybe. Let's see. No. Oh, it's so close to perfection. Oh, it's so upsetting. Plus 0.01. It's so close to perfection. Oh, at this point, manual offset. That's what we're doing. No. Minus. And 0, 2. 0, 2.3. A 0 to 4. Yeah, it's kind of. It looks like a shadow. Yeah, it's a shadow. That's what it is. Oh, it's actually consistent. Huh. That's good. That's very good. Great, so we'll have this now. Let me just also render this thing, because apparently I was overwriting the thing, so let me... Great. Now... Now what we have to do is add this, but not shift it to right, only shift it dot shift up times 2. And might as well actually money mirror. Flips and mirrors, yes. Great. Can we just add flip and it will be perfect, or probably not, right? That would be too good to be true. Oh, we can. I like the fact the numbers. Yeah, I like that. I like the idea very much. Now, it's time to not shift it up, only shift it. All of this aligns it. Okay, first of all, scale. If we assume that this gives us the actual scale, right, then what we need is for our thing. So this is the actual scale. We need 1/21 of this, I think. No, we need way smaller than 1/21. Let's just scale this. It's 4 and shift right times 4. There we go. Nope. There we go. That's 16. Great. And now all we have to do is put this over, because this is kind of like a double, which means divided by 42. Or maybe just divide by 21 and this times 8 and this times 32. Yeah, I suppose that could also work. Now let's just over here need shift up times 4 maybe. I don't know, I'm guessing it's one. I'm too tired to calculate these sort of things. It will be 2, right? That will be too perfect. Yeah, 1.5. Obviously, it will be larger than 1, right? So let's do 6/5. Yeah. 7/6. This would be way up, right? Yeah. 7. Yeah, that's good enough. Okay, great. Now let's just do 7 plus left times 2. Ah, so close. How about 2? Ah, it's actually very close. The size only should be a bit bigger. This should be 85, and the size should be like this, probably. Well, 82, and the size should be ever so slightly bigger, like 22. Wait, that means smaller, not bigger. Divided by 20, there we go. Alright, now it's a bit too big. How about 20.4? Yeah, that's how real pros do modding, by the way. They guess. They guess until it fits. And Yeah. Except now we have one more problem, which is the only now I realized manim number line logarithmic. That's what I was looking for. Log base, yes. So wait, we should just add scaling is equal to this. Yes, so we should probably just add well, first we should probably save this. Hayam budno? Oh, base of wood. Yeah, makes sense. Let's do it. Wood base? Base... Well... Not quite. What would be the base for this? Oh, I can't rethink. Okay, so... Well, -1, I suppose. That could be a base for this. I need... No, wait, it's base. Not -1, obviously not -1. We want halfway there to be... 1 divided by 2. I want over here. No, I'm just gonna write this. Maybe not in the rotated one. Lovely. Markup. This is 0.5, 0.75, 0.75 plus 125. That would be 875. Over here, the other way, but you get the idea. Kind of, at least. Well, the base won't do actually anything. Yeah, that's true. On the base, is there a possibility that this takes maybe 2 fingers in? Actually, we don't want log base. Wait. Yeah, we don't want log base. What we want is a different function. We want something that would give us... that would fit everything in between 0 and 1. I mean, there are loads of functions like that, but can we set the scaling? Random scaling. Scaling. Not scale, only scaling. Those are the only two. That's not good. That is very much not good, not optimal. I would even call that suboptimal. We need something that would cram the entire infinity in between 0 and 1. There are loads of functions like that, but we could do that manually, maybe? I suppose. Manual scaling? That could work. Alright, let's see. Get the range, point to number. No. Let's create the line. What we want is we want to create the line kind of manually. I don't really see a way to do it. We could just add the text below it. That, yeah, it's a dumb way to do it, but I mean, it's still a way to do it. Yeah, no saving, don't care. It's a very dumb way to do it, but I mean, might as well. Which basically would mean just putting a text below the thing. Include numbers, like all of this, just away. Excuse me. What happened here again? Oh my goodness. Why do you break all the time? If I do enter here. Didn't break this time. Cool. Great, now what we'll have to do is we will have to do Infty. That's what we'll have to do. Then now let's do, so that'll be 2, that'll be 4, so 8, 4, 2 and 1. Now all we need to do is we need to just normalize the distance. This will be a V group. So first of all, this shift, let's see how we'll do, and let's add the numbers. Great. Yeah, as expected. But wait, this is in the right place. Like 1 down and it's fine. Plus down times 0.5 and it's fine. Which means right now all we have to do is we have to just move them in the correct place. Should be relatively easy. Okay, shift. If we figure out how far we have to move it to right in order for it to be on the beginning, then we have everything we need. So this will be, can we guess? This actually won't give me much. So length of this is 9. It's scaled up 8 times, but it's 9 divided by 21 times 8. Wait, that's the length of the entire thing is 9 divided by 20. Yeah, so 9 divided by 21 times 8 times right divided by 2. Let's see. Yes! Oh, math. Science. Great. Lovely. Now we have this. We have... It's kind of aligned, but kind of is good enough for me. Because right now we just have to do left here. That's easy. We divide the entire thing by 2 because it's the thing. We could actually do it in a better way. More professional. But do I want to do it in a more professional way? Yeah, let's do it in a more professional way. So basically this one should go... This is our unit, basically. Yeah, so that way. Plus left times this times, and this is how far we want to go, from 0 to 1, which means if this will be 1, well, over here would be 0 obviously, but over here this would be 1 and 130. Yes, that's correct. Then over here this would be okay, first 2 would be 0.5, 4 would be 0.75, 8 would be 0.875, right? I think. Let's see now. Yeah, that works. Now all we need to do is just make them all red. Set color red and boom, this is done. This moved up somehow. How I won't even question it. Good enough, great. Now we have everything we need. We can go back to our lovely favorite paper. Oh, it's so bright all of a sudden. And we can just add those things. Being moved in a very specific way. Now, step by step. Obviously smaller, way smaller. Obviously, but smaller, in all directions like this. And yeah, I don't really like the margin 0 because we already have a margin in the picture, because someone didn't think about that and just did the animation, well, not the animation. And now we have to just go this. Yes. First, we start with a number line going from number line. Oh, why have I always write together? Going from 0 to infinity. Great. Now 2. Once again, unbelievably large, unnecessarily unbelievably large. This. Then we select everything from 1 to infinity. There we go. Yes. I should probably add all of them. Make it easier for myself. This. Four. Music while chop and art is absolutely wonderful. Okay. How did you even up, please? Moving images in Google Docs is always such a pain. Where am I? Okay, I'm in quantum physics, which is wrong. We should be up here. Oh, this is such a mess now. Oh my goodness. Oh, this is turned into such a mess. Yeah, great. Over here. Sick. Wonderful. That one will have to be bigger. I need to actually see the thing. Not that big, but definitely bigger. Yeah, that's good enough. I think then we select everything from 1 to infinity. Then we flip it the other way. Okay, it would be easier to show with an animation, alright? But it's a PDF, so flip it the other way. Wait, let's click. There we go. It. Put it in between 1 and 0. And then we just, well, it's not logarithmic. Actually, it is logarithmic. It's just from 1 to 0. Make the increase logarithmic. Yeah, this one is wrong. They should be just infinitely small. Go the smaller the spacing in between numbers. Yes, there we go. And this tells us which number inputted in red. Tells us. My brain is mush after we did that. Let me just. Which tells us will tell, and this tells us where the number inputted in red will end up after dividing 1 by it. Or in other words, tells us the solution to the equation. Nope, wrong thing, but I'm so glad it keeps like that. Great. Solution to the equation. My goodness, no, you are not supposed to be with that text. How? Even? Why? What? What just happened? Why? What? That is impressive. I've never... That is just straight up impressive. I know how I even did that. Great, we're back. Wow, okay, great. Anyway, back to this. Doesn't matter. Let me just into the equation. That a 1 divided by b, which basically means b in red. We cannot turn equations red. Where b is our input number. Great. Mathematically, full division, probably should add. Full division could be described as this because we just take that and we multiply it. Great. Sick. Wonderful. Did that. Now we have subtraction, right? No, we don't have subtraction. Subtraction can be defined as addition it wouldn't be addition, it would be as adding a negative number. Negative number being, well, there, I guess negative numbers kind of are defined by subtraction, and subtraction is kind of defined by negative numbers. Just assume that's true, so being the opposite version of a number which after added will result in a 0, so that over here it would be just a plus minus a is equal to 0. If you want to subtract b from a, in this case it would be just a minus b is equal to a plus b times -1. Great. Great. So you have subtraction, division. These two. And the only problem is roots and logarithms. Well, roots and logarithms are a bit more annoying, but... Well, logarithms aren't actually. Logarithms are unbelievably easy to explain. Logarithms are Logarithms. Logarithm is an operation for C. No, wait, no, for B in a following equation. Just like this, if we have a to the power b is equal to c, then logarithms look for b. Not for example.
Wait a minute, where are we going?
Oh, to the party.
Wait, I just realized something. When you have inside a number, right? Okay, I know this is not the hyper-operational mathematics live stream, but I just realized something. Our original equation, a n b n plus 1 negative should work. It should work because this is why it's an anti-operation. You operate on an anti-number. Yeah. That's why it's an anti-operation. I am such an idiot. That's so obvious now. Yeah. Negative. Oh my goodness, so obvious. That's so obvious. Oh, okay, great. Oh, fuck me. Retrospectively, it's very obvious. Obviously. Okay, well, glad to know that now. I will just add it to the hyper-operational relaxed paper. Which looks like this. And over here will be just log base a right is equal to b. I feel like that's it. That's all you have to explain for logs. Maybe log properties. Maybe that could be useful. Log properties, yeah, maybe. But I mean, log properties can be derived from exponential properties. Well, yeah. I should really still mention log properties. I mean, I shouldn't. No, I'm working on the video which is called Don't Think. And the entire video is basically this from now, right now. Let's see, how much have we done today? Well, first of all, table content is massive. Too massive, some may even add. Well, I guess for now that'll be it. I'm I'm starving. So, that'll be it. Thank you so much for watching, and have a great day. Bye!